Hey everyone, back. So I will continue to central limit theorem part 2. So why it is important and what happened. So let's summarize it now, and then you will see how it is important. So what happened? So we took samples. So first thing was that we take samples, and then for each sample we take average. For each sample, so we find the average. Okay, and then we find the average of averages. This was the summary what we did. Okay, but then the importance of the central limit theorem comes this way. So it says that the sample average, so it will always be the Gaussian. Sample average will be always Gaussian. However, it's very important, the population may not be Gaussian. So the United States population, you are looking for who is the next president. It may be that the population decisions are not Gaussian, but the sample average will be Gaussian. That is very important here. So, okay, this is not the final. The final thing comes now. Okay, let me just put the main part. So this one is very important. Okay, the first thing is that central limit theorem says that the grand average will be approximately as the population average. This one is very, very important. So you take samples, and from these samples you find some average. Yes, you find the gear diameter, you find it as the 75 mm. Okay, so what it means is that the population of the gears that you manufacture, it will be around 75 mm. This one is the point one. The point two is that, so you give this one, yes, how certain you are. Or if you go other way around, the uncertainty of the measurement. So you're just looking for the plus minus side. Yes, plus minus the how far. For example, you say that average is 75 plus minus 8, or 75 plus minus 7. What is that? Which one is true? So that is also given by this the central limit theorem. It says that, so it is given, quantified, I would say that, not given, it is quantified by the standard deviation. Okay, this is the second important part, and let's see next slide. The first thing is, as n becomes larger and larger, so the n, if you remember, was the number of, in our case, example case, it was number of gears in each sample, and as the number of gears in each sample becomes larger and larger, the grand average becomes the same as the population average, and this one is the, so let me just put it here, the standard deviation of a sample average, So let me just go back to Excel and show how do you calculate it. So we have the, sorry, I should go to Excel. Yes, so I'm just trying to find the x bar. Yes, this is what you are trying to find. It will be the standard deviation. You have to be careful here. You have standard deviation of the sample, and then I would just select the same numbers, and then click on it. So this is sx bar, and the population, this one is the sigma, and the sigma is the population standard deviation. The The population standard deviation divided by the square root of n. I told you n is number of years, and that will give us the, so let me just go back to here. So I will find the population standard deviation, STD, or just sigma. For that one, it will be just the Sx bar multiplied with, you can see, multiplied with the square root of the n value. And the n value was 49, if you remember. Okay, this one is the population. If I go back to the slides here, the n value was, let me just see, n was a 49, yes, 49 and 108. So let me just put it here. The n is 49, the m value is 108. So I will talk about in our next slides that how do we use this sigma. So how do we use it, have to use it for uncertainty, or you can say the confidence. How confident are you that your average is in this range? Okay, this is given by the sigma, and also we will talk about in the next slides. If we have the smaller n, the n is less than 30, the population mu is not equal to the, so in this case the population mu is not exactly the same as the grand average, but you can again find the population average by x bar plus minus the t alpha by 2. This is the t distribution. It is very similar to normal distribution, but it is named as the t distribution, s by the square root of the n. So I will talk about this one in our future slides. So this one is in future slides, but this is just a summary of the central limit theorem, and then the time is to talk about the next part. I will solve problems. Thank you for watching.